Hi friends, welcome to Intra NXT Networking Made Simple. My name is Kishore and today we are going to start a topic DHCP, Dynamic Host Configuration Protocol. Have you ever wondered how does your phone, your laptop or your smart fridge gets an IP address the moment it connects to the home Wi-Fi? Well, that's exactly what DHCP does. Before we start the topic of DHCP in detail, I want to explain little on IP address and why it matters. Every device on network needs an IP address. It is a unique virtual address which is required for every device to connect to the network. Using the same IP address, it connects to the internet. You can browse your emails, you can access a movie, and so on. Let's do an IP address analogy with house address. Think of an IP address like your home address with house number and the street address. Consider you have ordered a pizza online from some of the app. In your app, while you order pizza, you also provide your house address details. Since you provide your house address details, the pizza delivery driver knows where exactly pizza has to deliver and he could deliver it to the correct location. Similarly, let's take another example. Here, in this example, I am taking a real use case of IP address. Consider you're watching a YouTube video on your phone. You have tapped a video and you want to watch BBC News. Your phone has an IP address 192.168.1.1 and it is connected to the internet. It's like your phone provided its own IP address details to the internet and in return it is asking a BBC News stream. In returns, a BBC News stream comes to your phone and you watch that video. Let's take another example of your laptop sending a print request to the network printer. Here, consider your laptop is somewhere in far location and it knows the printer which is somewhere in your office. Consider your printer IP address is 20.1.1.128 and you have already added the printer details to your laptop. The moment the laptop gives a print request, the print request travels all the way from the internet and reaches out to the printer and the print job takes place. And that's because the laptop knows the printer IP details. Before DHCP, the traditional method of IP address assignment was static IP address allocation. In this case, administrator used to feed the IP address details, subnet mask, gateway, and the DNS details to the end equipments. Let's understand some of the drawback of static IP allocation. Imagine doing this for the billions of devices today on the network. Today, with the rise of IoT, devices like your fridge, camera, car, and even garage doors are all connected to the network. Managing this massive number of connected devices manually has become an impossible task for the network administrator. It's not only painful but also error prone. Let's understand some of the common error by the administrator while using static IP allocation. If two devices ends up with the same IP, both will get kicked off from the network. Here in this example, the two computers are connected to the same switch. An administrator assigned IP address 192.168.1.100 to both the laptops or the computers. The moment both the computer broadcasts its IP address to the switch realizes this both the computers holding the same IP address and it kicks off both the computers from the network. So far, we covered high level of DHCP the IP address and its importance, the traditional way of manual IP allocation, and the drawbacks of static IP allocation to the end equipments. Now we are going to cover DHCP in details. Let's start DHCP and understand some of its key terminologies. They are DHCP server, DHCP client, DHCP pool, which is also known as DHCP scope, DHCP lease, and DHCP reservations. Let's understand each component in a greater details. DHCP server, which is also the device responsible for assigning the IP address automatically to the end equipments. DHCP client is the one asking for the IP address the moment it connects to the network. Like some of the client examples are your laptop, your phone, and the printer. While it connects to the network, the first thing it does is looking for an IP address so that it can communicate to the internet. DHCP server role. Who can own the role of DHCP server? So I have brought this topic considering there is an assumption on many of the minds that the role of the DHCP server can always be taken care by some of the servers that can be Windows or the Linux or some other server. But is that the fact? So we are going to cover here what other devices in the network can take the role of DHCP server to release the IP address to the end users. So the first is the servers like Windows Server, Linux Server, Infoblox Server, and so on. The other important components like multi-layer switch in the network can also take the responsibility of DHCP server, and along with that, the routers in the network, which can act as the gateway, also can take the role of DHCP server. The third key terminology, which is DHCP pool or the DHCP scope. In the DHCP server, administrator defines a range of IP address that can be assigned to the client. This defined range is known as DHCP pool. Here you can see administrator is adding one of the pool with the subnet details, the pool details to the server, and the same pool will be used by the server for the end clients. Here you can see the pool is created for the server and IP is getting released one by one to the end equipments as and when they join to the network. Let's take an example of a real-time scenario where DHCP pool is completely consumed and new devices cannot receive IP address. Here in this example, you can see DHCP pool is completely consumed and there is a warning of empty pool. What next? Now the administrator job begins. The administrator analyzes why the pool is exhausted, possibly due to the new users, devices, or the functional team joined the network. Based on the assessment, the admin expands or adds a new DHCP pool to meet the demand. Here you can see the old pool and the new pool. In the new pool, the IP from 192.168.10.101 to 192.168.10.150, where the 50 new users can be accommodated under this pool. And that's how this problem can be sorted out. Let's jump to the another key terminologies, which is DHCP lease. When the DHCP server assigns an IP address, it is given for the limited time period called lease time. This is exactly the way we take a house or a shop lease with a fixed time agreement. And when the agreement time expires, we have either to go and renew the agreement or surrender the property, and that property can be given it to any other interested party. Similarly, DHCP server provides a lease of IP address for a fixed time period. Here, in our example, you can see the IP address 192.168.1.100 is provided to the end device for 48 hours. Once the lease time reaches 50% of its duration, which is 24 hours, the end device starts the lease renewal process, and in returns, server extend the lease for the next 48 hours. In the event end device fails to renew the lease process, the IP address returns to the pool and can be assigned to another device. Let's cover the fifth key terminology, which is DHCP reservation. What is DHCP reservation? It is a feature in DHCP server that allows the administrator to reserve a specific IP address for a particular device. Here in our example, a DHCP server with a pool starts with 192.168.1.50 to 1.100. All the IP addresses are shown here without any reservation except the one which is 192.168.1.75. It is binded with the MAC address of a device. That means when a different device joins the network, DHCP server looks for the MAC address of the end device, and if it matches with the MAC address of an end device as defined in the DHCP pool for 192.168.1.75, in our case it is for the printer, that IP gets released. That means even though DHCP server automatically assigns IP from a pool, this specific device always receives the same IP every time it connects to the network. Let's understand one of the key processes in DHCP, which is DORA. The full form of DORA, where D refers to DHCP discover, O refers to DHCP offer, R refers to DHCP request, and A refers to DHCP acknowledgement. Here we'll uncover what is the kind of communication which happens between the DHCP server and the client when client connects to the network and DHCP server offers an IP address. Here, in our example, DHCP server is on our left side and a new DHCP client has joined to the network. And since it do not have any IP address, it is actively looking for an IP address from the DHCP server. Let's understand what is the process of getting an IP address. Step 1. Client initiates the discovery as it's looking for an active IP address and it is trying to discover who is the DHCP server who can offer an IP address to him. In this process, client sends a broadcast message into the network and he puts the source IP as 0.0.0.0 and destination IP address which is 255, 255, 255 and 255, which is a broadcast address, with the source MAC address of its own and the destination MAC address as all Fs, which is a broadcast MAC address, with the destination port as port 67, which only can be listened by the DHCP server at the transport layer. This DHCP message is received by all the clients in the network along with the DHCP server, but only DHCP server recognizes the port number 67 and respond with DHCP offer. In this message, DHCP server sends its own IP address, the MAC address detail, but the destination IP addressed as the broadcast IP since the client did not receive the IP yet, with the destination MAC again as the broadcast address. This broadcast message received to all the clients in the network but the client who requires an IP address responds with DHCP request. This message is broadcast in network layer but unicast in data link layer. You can see for the destination address, client has included the MAC address of server. Once this message is received by the server analyzes its pool and identifies the IP address for the respective client MAC address, and it acknowledges with the client IP address. This message is broadcast in layer 3, which is network layer, while unicast in layer 2 in the data link layer. And that's how the entire cycle of IP exchange between the server and clients takes place. With that, I want to conclude this session. If you found this video helpful, do not forget to like the video, subscribe to the channel, and press the bell icon for more tech insight. I would love to hear from you. Please drop a message and I will respond as the time permits. Thank you.